The United States Air Force just shattered every rule of jet engine design. On March 21, 2025, President Trump revealed an engine so revolutionary that it can literally transform itself while flying at Mach 2. This isn't science fiction. It's the adaptive cycle engine powering the F-47 fighter, and it represents the biggest breakthrough in aviation propulsion since the invention of the jet engine itself. While enemies struggle with engines locked into single performance modes, American pilots now command aircraft with engines that morph between fuel-sipping efficiency and raw, devastating power in seconds. The technology is so advanced that it sounds impossible. An engine with 3 separate airflow streams that reconfigure themselves based on combat needs. China's new prototypes. They're already obsolete before they finish testing. Russia's latest fighters, they can't even comprehend what they're facing. This engine doesn't just power an aircraft, it redefines what's possible in aerial combat. The numbers alone will shock you. Over 1,000 nautical miles of range with Mach 2 plus performance, all from an engine that generates more electricity than some power plants while staying completely invisible to enemy sensors. Welcome to Jet Insight, where we reveal the military innovations that keep America dominant. What you're about to discover about the F-47's engine technology will show you why this single breakthrough has changed aviation forever. The engine revelation that shocked the Pentagon picture. The moment on March 21, 2025, when President Trump stood in the Oval Office alongside Defense Secretary Pete Hegseth and Air Force Chief of Staff General David Alvin to announce something that would rewrite aviation textbooks. The F-47 fighter wasn't just another aircraft. It was powered by an engine so advanced that it had been secretly flying for 5 years, while the world debated whether such technology was even possible. Trump's words carried weight when he declared the F-47 had the most power of any jet of its kind ever made.
And we're confident that it massively overpowers the capabilities of any other nation. There's no other nation. We know every other plane. I've seen every one of them. And it's not even close. This is a next level.
But power was just the beginning. The real revolution lay in how this engine achieved that power, while simultaneously delivering unprecedented fuel efficiency and stealth characteristics. General Alvin revealed that experimental versions of this engine had been proving concepts and testing capabilities since 2020, accumulating hundreds of flight hours. While competitors were still drawing blueprints, American engineers were already perfecting an engine that could do the impossible. Be 2 completely different engines in one package. The designation F-47 honors the legendary P-47 Thunderbolt. But this new fighter's engine makes that World War II legend look primitive by comparison. We're talking about propulsion technology that operates on principles never before achieved in operational aircraft. Boeing's victory in this competition wasn't just about airframe design. It was about integrating revolutionary engine technology into a fighter that could utilize its full potential. The $20 billion contract specifically focused on harnessing engine capabilities that sound like pure fantasy. If you're amazed by this engine breakthrough, type "proud" in the comments below. The adaptive cycle, miracle that defies physics. Now let's dive deep into the engine technology that's making aviation experts worldwide question everything they thought they knew about jet propulsion. The F-47's adaptive cycle engine represents a complete reinvention of how fighter aircraft generate thrust and manage power. Traditional jet engines face an impossible choice. They can be optimized for fuel efficiency or maximum performance, but never both. It's like being forced to choose between an economy car and a race car, with no middle ground. Every fighter jet ever built has accepted this limitation as an unchangeable law of physics. The F-47's next-generation adaptive propulsion engine destroys that limitation completely. 2 American aerospace giants, General Electric with their XA-102 and Pratt & Whitney with their XA-103, are competing to power this revolutionary fighter. Both engines feature 3-stream adaptive cycle designs that literally reconfigure themselves during flight. Here's where it gets absolutely mind-blowing. While flying, the engine can change the amount of air bypassing its compressor core. In high bypass mode, the engine operates like the most efficient airliner power plant, maximizing range and endurance. But when combat demands arise, it instantly transitions to low bypass mode, delivering thrust levels that exceed anything previously achieved. The engineering behind this transformation is staggering. Internal airflow passages physically adjust their geometry. Variable inlet guides redirect massive volumes of air. Computer-controlled systems manage these changes thousands of times per second, optimizing performance for whatever the mission demands. Think about what this means in real combat situations. An F-47 pilot can cruise efficiently across the vast Pacific Ocean, covering over 1,000 nautical miles while burning minimal fuel. Then, when enemy fighters appear on sensors, the engine instantly transforms into a powerhouse capable of accelerating beyond Mach 2, while providing energy for every onboard system. But the adaptive capability goes even deeper. The engine doesn't just switch between two modes. It can operate at any point along the efficiency-performance spectrum. Need moderate fuel savings with good acceleration? The engine configures accordingly. Require maximum stealth with reduced heat signature? It adjusts internal airflow to minimize thermal emissions. The three-stream design is particularly revolutionary. Traditional engines have two airflow paths, through the core and around it. The F-47's engine adds a third stream that can be varied independently, providing unprecedented control over thrust characteristics, fuel consumption, and thermal management. The power generation revolution inside the engine. Beyond propulsion, the F-47's engine serves as a flying power plant that generates electricity levels never before achieved in fighter aircraft. This isn't just about powering traditional systems. It's about enabling capabilities that transform how fighters operate in combat. The engine's electrical generation capacity exceeds that of many ground-based facilities. This massive power output feeds the F-47's advanced radar systems, electronic warfare equipment, directed energy weapons, and the computational systems needed for artificial intelligence integration. Traditional fighter engines struggle to provide enough electrical power for modern avionics while maintaining flight performance. The F-47's adaptive engine solves this problem by dedicating specific airflow streams to power generation without compromising thrust production. The cooling systems integrated into this engine are equally revolutionary. Managing the heat generated by both propulsion and electrical systems requires airflow redirection techniques that work seamlessly with the adaptive cycle operation. Internal air passages cool critical components while maintaining the engine's stealth characteristics. Heat signature management represents another breakthrough. Enemy infrared detection systems rely on identifying the hot exhaust signatures of fighter engines. The F-47's adaptive engine can modulate its thermal output, essentially controlling how visible it appears to infrared sensors. The engine's power generation also enables the F-47's ability to control collaborative combat aircraft. Managing multiple drone wingmen requires computational power and communication systems that demand enormous electrical capacity. The adaptive engine provides this power while maintaining all flight performance characteristics. Stealth integration that makes the engine invisible. The marriage between the F-47's adaptive engine and its stealth systems represents engineering artistry at its finest. This isn't just about hiding an aircraft. It's about making an incredibly powerful engine virtually undetectable across multiple spectrums. Acoustic stealth presents unique challenges for powerful engines. The F-47's adaptive cycle technology includes sound dampening systems that actually use the variable airflow streams to cancel engine noise. By controlling how air flows through different sections, the engine can minimize its acoustic signature. Radar stealth integration focuses on the engine inlet and exhaust designs. Traditional fighter engines create radar reflections from their internal components. The F-47's engine uses specially designed inlet geometries and radar-absorbing materials throughout its airflow passages to eliminate these signatures. The exhaust signature represents perhaps the most challenging stealth requirement. Hot exhaust gases naturally create infrared and radar signatures that enemy sensors can detect. The adaptive engine addresses this through innovative exhaust mixing that rapidly cools exhaust gases while dispersing them to minimize detection. Internal cooling airflow serves double duty in the stealth integration. Beyond protecting engine components, these airstreams help manage the overall thermal signature of the aircraft. The engine can actually adjust its cooling patterns to minimize infrared detection during critical mission phases. The electromagnetic signature control is equally sophisticated. The engine's electrical generation systems use specially designed components that minimize electromagnetic emissions. Even with massive power generation, the F-47 maintains electromagnetic stealth characteristics. Range revolution that changes Pacific strategy. The F-47's adaptive engine enables operational ranges that fundamentally alter strategic calculations across the Pacific theater. We're not talking about incremental improvements. This represents a complete transformation of how American air power can be projected across vast ocean distances. Current fighter aircraft face severe range limitations when operating in the Pacific. The F-22 Raptor and F-35 Lightning II, despite their advanced capabilities, require multiple aerial refuelings to reach distant operational areas. This creates vulnerable points that enemies can target and limits operational flexibility. The F-47's adaptive engine changes this equation completely. By optimizing fuel efficiency during transit phases, the fighter can cover more than 1,000 nautical miles without refueling, while still retaining fuel for extended combat operations. This isn't just impressive, it's strategically revolutionary. Consider the tactical implications. F-47s can operate from bases positioned safely away from short-range ballistic missiles that countries like China have developed specifically to target American forward airfields. Our pilots can launch from secure locations while still reaching any potential conflict zone with operational fuel remaining. The engine's efficiency during cruise flight approaches that of commercial airliners, but with the instant ability to transition to combat power when needed. This dual capability means F-47 pilots can patrol enormous areas, providing persistent coverage that was previously impossible with tactical fighters. Extended range also enables multiple attack profiles that confuse enemy defenses. F-47s can approach targets from unexpected directions, having flown circuitous routes that traditional fighters cannot manage. The adaptive engine provides the fuel efficiency needed for these complex flight profiles. The strategic uncertainty this creates for potential adversaries cannot be overstated. Enemy planners can no longer predict American fighter operations based on known base locations and fuel limitations. The F-47's engine-enabled range means threats can emerge from any direction across the Pacific. Combat performance that redefines air superiority. When the F-47's adaptive engine switches to maximum performance mode, it delivers combat capabilities that exceed anything previously achieved in fighter aviation. The transition from efficient cruise to devastating combat power happens in seconds, giving American pilots overwhelming advantages in air-to-air engagements. The engine's maximum thrust output surpasses the F-35's current record-holding power plant, which generates 43,000 pounds of thrust. While exact F-47 thrust figures remain classified, President Trump's declaration of the most power of any jet of its kind suggests performance levels that dwarf current fighters. Acceleration characteristics benefit dramatically from the adaptive engine technology. Traditional fighters must compromise between initial acceleration and sustained performance. The F-47's engine can optimize itself for maximum acceleration when entering combat, then reconfigure for sustained high-speed flight during engagements. Mach 2 plus performance represents just the beginning of the F-47's speed capabilities. The adaptive engine's ability to optimize itself for high-speed flight suggests performance levels that approach the theoretical limits of what's possible with conventional fighter designs. Maneuverability benefits from the engine's power generation and thrust vectoring capabilities. The massive electrical output can power flight control systems that provide unprecedented agility. Trump's statement about maneuverability like nothing ever seen reflects these engine-enabled capabilities. Sustained combat performance represents another revolution. Traditional fighters experience rapid fuel consumption during combat operations, limiting engagement duration. The F-47's adaptive engine can balance combat power with fuel conservation, extending fighting endurance significantly. The engine's responsiveness to pilot commands creates an almost telepathic connection between aviator intent and aircraft performance. Advanced engine control systems interpret pilot inputs and configure the engine for optimal response faster than human reflexes could manage. Collaborative combat aircraft coordination. The F-47's adaptive engine enables revolutionary coordination with unmanned collaborative combat aircraft, creating force multiplication effects that transform the mathematics of aerial warfare. This isn't just about flying with drones. It's about commanding an aerial fleet powered by engine technology that makes such coordination possible. The Air Force envisions each F-47 controlling multiple drone wingmen through systems powered by the adaptive engine's massive electrical generation. These collaborative combat aircraft extend the fighter's reach while providing additional firepower and sensor capabilities. Communication with multiple drones requires computational power and transmission capabilities that traditional fighter engines cannot support. The F-47's engine provides the electrical capacity needed for real-time coordination of complex drone formations while maintaining all flight performance characteristics. The tactical flexibility this creates is staggering. An F-47 pilot can deploy drones for reconnaissance while remaining at safe distances, then coordinate attack patterns that overwhelm enemy defenses. The adaptive engine ensures that controlling these additional aircraft doesn't compromise the fighter's own performance. Drone coordination during high-speed flight presents unique challenges. The F-47's engine control systems can maintain formation leadership while communicating with drones traveling at different speeds and altitudes. This requires computational resources that only the advanced engine can provide. The psychological impact on enemies facing F-47 formations cannot be understated. Instead of engaging single fighters, adversaries must contend with multiple aircraft working in perfect coordination. The adaptive engine makes this level of integration possible, manufacturing precision that builds the impossible. Creating the F-47's adaptive engine requires manufacturing precision that pushes American industrial capabilities to new heights. Boeing's St. Louis facility incorporates production techniques specifically developed for these revolutionary power plants. The engine components demand tolerances measured in microscopic increments. Variable geometry systems that reconfigure during flight require manufacturing precision that exceeds anything previously achieved in production aircraft engines. American manufacturing technology has risen to meet this challenge. Advanced materials used throughout the engine require specialized fabrication techniques. Heat-resistant alloys, radar-absorbing composites, and electromagnetic shielding materials must be integrated without compromising the engine's adaptive capabilities. This represents manufacturing artistry at its finest. Quality control systems monitor every aspect of engine production. Each component undergoes testing that verifies performance across the entire range of adaptive configurations. This ensures that every F-47 engine can deliver its full range of capabilities throughout its service life. The production timeline for these engines reflects both urgency and precision. Boeing's investment in new manufacturing capabilities began before the contract award, demonstrating confidence in their ability to build these revolutionary power plants at scale. Workforce development programs prepare skilled technicians specifically for adaptive engine production. The manufacturing techniques required are so advanced that entirely new training programs were necessary to prepare American workers for this challenge. Global implications of engine superiority. The F-47's adaptive engine technology creates global implications that extend far beyond American air power. This breakthrough forces potential adversaries to reconsider their entire approach to fighter aircraft development, while providing allies with access to revolutionary capabilities. China's recent stealth fighter prototypes, revealed in December 2024, represent their attempt to challenge American air superiority. However, these aircraft rely on conventional engine technology that cannot match the F-47's adaptive capabilities. The technology gap has actually widened despite Chinese efforts. Russian fighter development programs face even greater challenges. Their inability to develop reliable conventional fighter engines means that adaptive cycle technology remains completely beyond their current capabilities. The F-47's engine advantages create gaps that cannot be closed through traditional development approaches. Allied nations are expressing intense interest in F-47 technology. President Trump's mention of allies, calling constantly about acquiring the aircraft, reflects global recognition of the engine's revolutionary capabilities. Export versions may provide allies with access to scaled versions of this technology. The industrial base implications extend beyond just engine production. Countries seeking to develop competitive fighters must now master adaptive cycle technology or accept permanent inferiority. This raises the barrier for entry into advanced fighter development significantly. Strategic stability benefits from American engine superiority. The overwhelming technological advantages provided by the F-47's power plant actually reduce the likelihood of conflicts by making successful challenges to American air power virtually impossible. Testing triumphs that proved the impossible. Behind the F-47's engine success lies a flight test program that validated technologies most experts considered impossible. The experimental aircraft that have been flying since 2019 proved that adaptive cycle engines could deliver on their revolutionary promises. The DARPA X-plane program that preceded F-47 development specifically focused on proving engine technologies under real flight conditions. These aircraft accumulated hundreds of flight hours while testing engine configurations that had never been attempted in operational aircraft. Flight test data validated the engine's ability to transition between performance modes during actual combat maneuvers. Test pilots pushed these experimental engines through scenarios that simulated the most demanding combat conditions, proving reliability under extreme stress. Engine durability testing exceeded all expectations. The adaptive mechanisms that reconfigure airflow streams demonstrated longevity that surpasses traditional fighter engines despite their complexity. This reliability enables the F-47's extended operational capabilities. Performance verification confirmed that the engine delivers on its revolutionary promises. Range, speed, maneuverability, and power generation all met or exceeded design specifications during flight testing. The technology works exactly as intended. The secrecy surrounding these test flights demonstrates American capabilities in advanced technology development. While competitors struggle with public programs that reveal capabilities and limitations, the F-47's engine testing remained hidden until official announcement. For our military veterans and aviation enthusiasts watching, we'd love to have you join our community of service members and supporters who share insights about these incredible technological achievements. Your experience helps us understand the true significance of these developments. The strategic vision behind engine revolution. The F-47's adaptive engine represents more than technological achievement. It embodies a strategic vision for maintaining American air superiority through revolutionary propulsion capabilities that cannot be matched by any potential adversary. Air Force leadership recognized that incremental engine improvements would not provide the advantages needed for future conflicts. The adaptive cycle breakthrough required fundamental rethinking of how fighter engines operate and what capabilities they could provide. The engine development program specifically addressed Pacific theater requirements, where vast distances and limited basing options create unique challenges. Traditional engines could not provide the range and performance needed for effective operations across these expanses. Integration with emerging technologies like artificial intelligence and collaborative combat aircraft required electrical generation capabilities that conventional engines could not provide. The adaptive engine specifically addresses these power requirements while maintaining flight performance. The modular design philosophy extends to engine development. Future engine improvements can be integrated without requiring entirely new aircraft, ensuring that the F-47's propulsion capabilities continue advancing throughout its service life. International cooperation aspects of engine development strengthen American alliances while sharing development costs. Partner nations that contribute to engine technology gain access to revolutionary capabilities while reinforcing collective defense. Conclusion: the engine that changed everything. The F-47's adaptive cycle engine represents the most significant breakthrough in fighter aircraft propulsion since the invention of the turbojet engine itself. This revolutionary technology doesn't just power an aircraft, it redefines what's possible in aerial combat and strategic air operations. Every aspect of this engine, from its ability to reconfigure itself during flight to its massive electrical generation capabilities, demonstrates American engineering excellence at its absolute finest. Our enemies may attempt to copy these innovations, but they cannot replicate the industrial base and technological expertise that made this breakthrough possible. The brave pilots who will command these aircraft deserve nothing less than the most advanced propulsion technology our nation can develop. The F-47's engine ensures that American aviators will have overwhelming advantages in any conflict while providing the reliability needed to bring them home safely. This engine breakthrough also demonstrates American industry's ability to achieve the impossible when properly motivated and supported. Boeing's success in integrating this revolutionary technology shows that American aerospace companies continue leading the world in innovation and execution. The strategic advantages provided by the F-47's adaptive engine will influence global military calculations for decades to come. Potential adversaries must now account for American air power capabilities that exceed anything they can develop or deploy. As we look toward the future, the F-47's engine technology provides absolute confidence that America will maintain the air superiority that has preserved freedom and democracy around the world. Our commitment to technological excellence ensures that the skies will remain American-controlled for generations to come. The age of adaptive cycle engines has begun, and America owns this revolution completely. If you're as impressed by this engine breakthrough as we are, please hit that like button and subscribe to Jet Insight for more exclusive coverage of the technologies keeping America dominant in the skies. Let us know in the comments which aspect of the adaptive engine amazed you most. We love hearing from fellow aviation enthusiasts who appreciate American engineering excellence.